Okay, let's finish out the last 2 pages of the old exam. First step, we have TBS chloride. This TBS is a protecting group. There should also have been a imidazole written there. Imidazole was our weak base for that reaction. So this puts a protecting group on the alcohol. Second step, we're reacting with a very strong base. That very strong base is going to pull the proton off of the alkyne. Gives us that anion. Third set of reagents, we have an epoxide. This will do a ring opening of the epoxide. Be a negative charge on the oxygen now. There's the 2 carbons of the epoxide ring that broke apart. Left the negative charge on the oxygen. Now, last step, we're reacting with HF. That's acid, so the fluoride is going to take off the protecting group. We've also got the acid to protonate our oxygen there. So we get our original alcohol back. Made another alcohol. So we got our original back. Here is the one that we had protected. That takes the protecting group off, and then our acid also protonates this oxygen to give us the alcohol. So there's our product. And our next one here, we have HBr in the presence of a peroxide. We know the peroxide will break apart, give us peroxy radicals. That peroxy radical is what's going to react with the HBr. So that's going to get a hydrogen off of the HBr. And that gives us a bromine radical. So we have a bromine radical that's going to react with the alkene. We've also got an alcohol here as a byproduct there. Very small amount. Remember, we have very few radicals present. Now, this does the Anti-Markovnikov addition. Bromine added gives us the tertiary radical there. It's also a benzylic radical. Now, that's going to react with more of the HBr. That abstracts the hydrogen off of HBr, gives us our product, and gives us a bromine radical that can keep the reaction going. You also get a bromine radical that can go right back through the reaction again. So that was Anti-Markovnikov addition to the alkene. So if there were no peroxide there, then you're going through a carbocation, we would have had Markovnikov addition if there was no peroxide present. Next one here we have osmium tetroxide again. Yeah, we already had one of those before. Okay. I don't know why I have two of them on there. We got osmium tetroxide again. So the osmium tetroxide, that's going to react and add across the double bond. And then the hydrogen peroxide will break that apart. There's what you have after the first step, and then we react with the hydrogen peroxide. That cleaves the osmium off, and we wind up with a diol. Product, we get a diol. Okay, our next one here, we're reacting with mercury diacetate. So the mercury breaks apart, break off an acetate group, leaves off, gives a mercury cation. So you get one of the acetates coming off, that gives a mercury cation, and that's what adds to the double bond. You get the electrons out of the double bond coming out and adding. And I'm going to just temporarily put a plus charge there. Mercury went on to the least substituted carbon. That gives a plus charge on the most substituted, but that doesn't exist. The mercury reaches across and holds that in place. That's partial positive and partial positive on the mercury. Now, let's see what else we have. We have water, and the water is going to come in and add to that carbon of the partial positive. We'll give our electrons back to the mercury, whatever it reached over and gave to the carbon. Now you can use more water to pull off the extra proton. Base, grab off the extra proton, and that gives us an alcohol group on there. Now we're reacting with sodium borohydride. The borohydride is going to transfer an H- in. Mercury off. And that gives us our product. So we were able to hydrate the alkene. This is a hydration, and this also avoids any rearrangement. You get Markovnikov addition of water across the double bond, and we avoided any rearrangement. Now you also have to be careful with these reactions. This one had water in there, but we also covered, let's see, what did I have? Let's look at another one here. So I'm going to go back to that same alkene that we started with. So that one had water, but we also did them with an alcohol in here. Now if we had water, oh, there's a 2 there. If you had water, we made an alcohol. If you have an alcohol in here, we're going to make an ether. So if I'd had that alcohol that I've got written there, you can use any alcohol, does not matter, any alcohol will work. We still get Markovnikov addition. It'll go through that same mechanism, it's just that we're adding the alcohol instead of the water. So we wind up making an ether. So you're going to have to pay attention on the exam. Do I have water in there, or do I have an alcohol in there? If you have water, you get an alcohol as a product. If you have an alcohol, you get an ether as a product. Okay, that finishes the reactions. Now let's look at synthesis. So our next one here, I've given you the starting material, one of the starting materials. I've given you the product, and I want you to tell me everything that we need to get there. Now let's examine what we have. Got an alkene. Over here I see an epoxide. Hey, I recognize that. I know how to make an epoxide. We took MCPBA and reacted with an alkene. I don't have an alkene. Got to get there. Now we're starting with an alkane. The only thing, alkane doesn't have a functional group. There's nothing about an alkene that wants to react. We've got to have something pretty drastic to get an alkane to react. The only thing that we have covered that can make an alkane react, they don't want to react. The only thing that we've talked about that can force them to react is radicals. So I am going to first react with bromine, and we'll do this in the presence of light. You could also do very high heat. And we know the light will break the bromine apart, give bromine radicals. A bromine radical is going to abstract a hydrogen from somewhere, it doesn't matter where we go. So that abstracts a hydrogen, gives us the alkyl radical, and then that reacts with more bromine. Remember, very little broke apart, gave radical. Most of it's still together. So it's not a second equivalent, it's still just one equivalent. And that has put a bromine on the alkane. Now again, that's the only thing that we can do to get an alkane to react. They do not want to react. We've got to have a radical. We've got to have something that's very drastic to make the alkane force it to react. Now, remember we said we have an epoxide. Epoxides are made with MCPBA reacting with an alkene. So how do we get to an alkene? Well, I have a secondary alkyl halide. We know if we take a secondary alkyl halide and react with a strong base, any strong base, I'll just choose this one, but we could use any strong base. This will do an E2 elimination. and we'll make an alkene. So the base grabbed a beta hydrogen. Electrons kick in to form the double bond and kick the bromine off. That gives us an alkene. And then we already mentioned how to take the alkene to the epoxide. That's just MCPBA. Okay, so there are the reagents that we would need. We would react first set of reagents. I need to add, I'll put this as the first step, I need to add bromine in the presence of light, bromine and light. And then we're going to add in strong base. You need a good strong base to make the alkene. And third set of reagents, we'll add in MCPBA to make the epoxide. Okay, our next one. If you notice this one, we got an alcohol that we're starting with, and our product's an alcohol. The only difference is it's moved. How do I get it to move? Let's see what we can do. So there's a couple different, there's some options here. Now I put one set of reagents on the answer key that I gave you, but there are different options here. One thing that we could do is to use sulfuric acid and heat, so concentrated sulfuric and heat. That would dehydrate the alcohol. Now this needs to be high heat. It needs to be 180 degrees because it's a primary alcohol. If you use lower temperature, we talked about 140 will give us an ether. We want to make an alkene. So that will give us the alkene. So just acid and heat. And then we can take and just add acid and water. Any acid. So this would, you could use sulfuric or phosphoric or any acid and water makes hydronium. So just add hydronium. That would protonate the double bond and give us a secondary carbocation, and then water will add to that, and that would give us the product. So that's one way to do it. We could have reacted with phosphorus tribromide, or you could do thionyl chloride. Do thionyl chloride, it's a chlorine here, but if you do phosphorus tribromide, it's bromine on there. So that will substitute primary and secondary alcohols only. That is a primary. And then we could make the alkene. Now primary alkyl halide, I'd have to use the bulky hindered base. The bulky hindered base, strong bulky hindered base, that would do E2, and that would give us the alkene. And then you could add acid and water, and that would give that alcohol. So there's another option. There's different options for these. There's not always just one set way to do these reactions. Let's see, what else? We talked about a lot of ways here, going from the alkene to that alcohol. You could do acid and water. You could also do the oxymercuration-demercuration. That would be fine as well. Okay, so that's some different options there for that one. So there's not always just one set way to do it. So I don't know what you came up with. You may have thought of something else. The last question is some naming. That's on the old exam. So let's look at those real quick. Now we have a cyclic ether here. We talked about with the cyclic ethers, we use replacement nomenclature. We pretend that oxygen is a carbon, replace it with a carbon, name it, and then add the prefix oxo. So if that were a carbon, that would be a cyclopentane. And we simply add oxo to the front of that to represent that we have the oxygen in the ring. Now we also have a substituent hanging off. Our oxygen here in the ring is the 1 position, and we'll number on around to give our substituent the lowest number possible. So the lowest number we can give it is a 3 position. Now that is a methoxy group that is coming off, and substituents just go out in front in alphabetical order if we have more than one. So this is a 3-methoxy oxo cyclopentane. Our next one here, we've got 2 ether groups there. Easiest way to name those, when you've got more than one ether, you're going to have to use, name them as alkoxyalkanes. So our ring, that's a cyclopentane ring. We want to number it to give our substituents the lowest numbers possible. You have 2 substituents on this carbon, 1 over here, so we're going to start with the one with 2. So I've got an ethoxy on carbon number 1. I've got another ethoxy on carbon number 1, and a bromo would then be on carbon number 3. Substituents go out in the front in alphabetical order. You got bromo versus an ethoxy. So bromo comes first alphabetically. This is 3-bromo. 1,1-diethoxy. Since we have 2 of them, we're only going to list it once and use the appropriate prefix. You must tell the position of both of them. So it's a 1,1-diethoxy cyclopentane. Okay, that's the old exam. Now, I noticed we have covered so many reactions in these 3 chapters, Chapter 8, Chapter 10, and Chapter 11. Make certain you look at all of them. Just because it's not on the old exam doesn't mean it will not be on yours. So make certain that you look at every reaction that we covered, not just these that are on the old exam. So you kind of know what to expect, the level of difficulty, but you need to make certain you study all of the reactions that we've talked about.